Okay, welcome back to my channel. Make sure that you subscribe, you like, put up the comment. Yeah, if you can put up the questions, we're having problems. If you need more explanation, just feel free to leave those comments in the comment section. All right, so today I also have an interesting question about modulus functions, to redefine them. Once we define them, then we do what? We sketch. All right, this one, question B. So you can pause the video. Once you pause the video, then you can copy the question and we jot into what? Solving. All right, so we have been told to redefine a function k of x, which is equal to 2x minus 1, then minus x plus 2, like that. Beautiful stuff, huh? Beautiful. Okay, so for us to redefine this, we'll get these two functions out of these moduluses. Then we will ignore the sign in between. Then after we ignore the sign in between and we have gotten those two functions, we equate them to 0 so that we could find what? The breaking point or the critical values. All right, so we equate this. So let's say this is h of x. We assume to say this is h of x to be x 2x minus 1. We forget about the sign or we ignore the sign. Then we have, let this be f of x to be equal to x plus 2, like that. All right, so from there now we equate each to what? To 0, so that we find the breaking point or the what? The midpoint. All right, so this, if we equate this to 0, to be 2x minus 1 go to 0, even that is x plus 2 go to 0, then 2x is equal to 1, then x is equal to -2, then there x will be half. Okay, like that. So these are what? A critical point or the breaking point. All right, so now from there we want to see the behavior of the graph. Keep in mind to say a modulus function can't give you a what? A negative. If, for example, you have something to say the modulus of 2x minus 1 is equal to -2 to be the answer, this is not possible, and this question has no solution. Because a modulus can't give you a what? A negative. A modulus is always positive. A modulus is always what? Positive. More like you're always positive. So if you're always positive, just know that me, I'm what? I'm a modulus. No, you're not a modulus. But just know that you should always be what? Positive. All right. Then from there, since we have found the breaking point, now since a modulus is always a positive, we want to see where the graph will give us the what? The negatives, and we manipulate them to be what? To be positives. So we'll draw up the what? The sine graph. We'll draw the sine graph like this. All right, draw the sine graph. So when you're answering, this is just a order of you answering. Okay, you find the break points, then you draw the sine graph, then you follow. Okay, so now we'll get the two functions. So in the order of how they're coming out, so we'll say 2x minus 1, then there x plus 2. Okay, so since here just the overall. Okay, then we have what? We have two regions where x is equal to half and where x is what? -2. Okay, so according to the number line, negative has to come first, then a positive, right? Then a what? Then a positive. So positive half there. Then from there now, we can say this is a region. So we have three regions now. This region, and that region. So you say this region is where x is less than 2. And we have this region in between where negative 2x is less than x, which is less than also 1 over what? 1 over 2. And half should be greater than what? X. Right. Then from there now, you have to differentiate between the piecewise functions and the what? And the modulus function. A modulus function is a continuous function, while a piecewise function is a discontinuous. Alright? Is a discontinuous. Alright. So you can choose either to put the equal signs here or there or in between. But for me, I like putting the equal sign in between. Alright. So we put the equal sign there and there. Alright. Then from there now, we want to see the behavior of the the behavior of the graph, and want to eliminate where the negatives are, so that we just remain with just remain the positive, because the modulus is always a positive thing. Alright. So here, where x is less than 1, so we get the values where x is less than what? Less than negative 2. So what are numbers which are less than negative 2? So we have let's just say x is equal to minus 3, like that. All right, because 3 is less than negative 2. So if you plug in negative 3 here where x is, then you solve it. Then will the answer be negative or positive? So if you put negative 3 there, to be negative 6, negative 6 minus 1 to be negative 7. So negative 7, there's a negative there, and we are only interested in in the sign. So we have a negative here. So if you put 3 there, you're going to get negative 1. Then the whole value, if you multiply this time that, you have a positive, like that. Beautiful. The number in between 2 and half, a simple one, is 0. So if you get a 0, to say x is equal to 0, if you put 0 there, you're going to have what? A negative. If you put a 0 there, the answer will be what? Positive 2. And we're only interested in in the sign. So we have positive. Then there, if you multiply those, you're going to have what? A negative. Okay. Then a number which is greater than half can get 1. If you say x is equal to 1, if you plug in 1 there, the answer will be what? Will be 1, which is what? Which is a positive. Okay, which is a positive. Then if you plug in 1 there, the answer will be 3, and 3 will be what? Positive. All right, and the positive there. Okay. Then once you draw the sign graph, then where the negatives are, here is negative. This is where the graph will be negative. But want to manipulate these to be what? To become positives, because moduluses can't give you what? Can't give you a negative. Okay, so we rewrite this. We rewrite this in what? In 3 sets according to the 3 regions which we have. We write this in 3 sets according to the what? The region we have. Then you plug in these negatives and positives, so that the graph should change where it is positive, where it's negative, into what? Into positive. All right. So we say y. So we say y is equal to, you write this, you remove the moduluses, you introduce the parentheses, make sure that the sign is there. All right. So 2x minus 1, then minus x plus 2. So this is for which region? For where x is less than negative 2. Okay. Then for this region, since this region gave us this and that, right? This region gave us this and that. So for this function, it gave us a negative. So in front of this function, we're going to put the what? A negative, so that it can change into what? Into a positive. Then even this one, we'll put the side which we got from this function, so that we change it into what? Into positive. So here we introduce a negative in front because we got a negative when you plug a number which is less than -2. Even here we get what? A negative, which is there. All right. Then from there now we say y is equal to, here we have this times that, we have minus 2x, then plus 1, then here to be positive, right? Then since it to be a positive, it's just more like you're multiplying by 1. So it will be plus x plus 2 for the region where x is less than minus 2. Okay, y is equal to, so this and this are like terms. You collect the like terms. As usual. Then y is equal to this there is minus x, then plus 3. All right. So we have one region. All right. Then the second region, we say this in between. We say y is equal to, you copy the original function again. Say 2x minus 1, then minus x plus 2. 4 minus 2 is less than x, less than half, like that. Then put those microsine. Then for this region, the first function gave us the what? A negative. So in front of this function, we're going to put the what? A negative. Then since this is a positive, we put a positive, or a positive will have no effect because it's just a positive. All right. So this times that is minus 2x, then plus 1, then minus x, then minus 2 for that. So y is equal to minus 2x, then minus x, then plus 1, then minus 2. Then y is equal to, there I have minus 3x, then there minus 1. So this is for what? For this region. All right. Beautiful stuff, sir. Beautiful stuff. I hope you have followed cleanly, because you are almost killing the question. All right. So the third region now, the third region is where half is greater than x. Half is what? Greater than x. So we will write the function again. Y is equal to 2x minus 1, then minus x plus 2. For half is greater than what? Greater than x, like that. All right. So here, for this function, it gives us a positive. First function gives us what? A positive again. So we'll put positive there, even there positive. So y is equal to, if you multiply this, it will be 2x minus 1, then positive, the negative times positive is negative, then you have minus x, then minus 2 for that. Then y will be equal to this minus that, then minus 1, then minus 2. Then y is equal to, there it's x, then there it's minus 3. Okay. So you have, so now we have redefined this modulus function. So it's to now be k of x, then is equal to, then to be equal to, so the first region where x is less than 2, it gave us negative x plus 3, negative x plus 3. So this one is 4, where x is less than negative 2. Then for the region in between, it gave us minus 3x, then minus 1, 4, x for negative 2 is less than or equal to x, less than or equal to half. Then x minus 3 for the region where half is greater than what? X. So this, you have what? You have redefined the modulus. You have redefined the what? The modulus is. So you find some questions which looks like this, then they'll tell you to say, brought the question. So in several occasions, piecewise functions are the one which comes like this, where like they have already redefined them. They just want you to what? To plot. All right. So I will show you two methods on how you can handle these types of what? These types of graphs. Okay. So the first one is that for you to plot that, we have y is equal to minus x, then plus 3, minus x plus 3, 4. The region where x is less than negative 2, and y is equal to minus 3x, then minus 1. For the region where negative 2x is less than x less than or equal to half, then y is equal to x minus 3, 4. Region where half is greater than or equal to, not greater than or equal to, but it's greater than, just greater than x, like that. Okay. Now from there now we'll find the what? We'll find the table of what? Table of values. So for this one, y is equal to minus x plus 3. So just do this. Then x, then y. So just say let x be minus 2, minus 1, 0, 1, and let's just say and 2 there. Then we find the value of what? We find the value of y. So if x is 2, if we plug in 2 here, then y will be what? Y will be 5. If we plug in 1 there, then y will be 4. If you plug in 0 there, then y will be 3. If you plug in 1 there, then y will be 2. If you plug in 1 there, then y will be 1. Like that. All right. Like that. Okay. Then we say y is equal to, for this now, we say minus 3x, then minus 1. Then we make also what? Its table of what? Its table of values. Its table of values. Okay. So x, then y. Then we assume to say let x be minus 2, minus 1, 0, 1, and 2. You can even continue, but let's just end where it's 2. All right. So if you plug in 2 there, then negative 2 multiplied by negative 3, we have positive 6. Positive 6 minus 1, we have what? We have 5. Then there, if you put 1 there, we have what? We have there it will be 4. There it will be 4. Then 4 minus 1, it will be 3. Then if you put a 0 there, you're going to have what? A minus 1. If you put a 1 there, you're going to have a minus 4. If you put a 2 there, you're going to have a minus what? A minus 7. Good. Okay. Then y is equal to x minus 3. Then also make it what? Its table of values. Okay. Then there x, y. Then say negative 2, minus 1, 0, 1, 2. Like that. Okay. Then we say if x is 2, then y will be what? Minus 5. If x is negative 1, then y will be what? Minus 4. If x is 0, then y will be what? Minus 3. If x is 1, then y will be what? Minus 2. If x is 2, y will be what? Minus 1. Like that. Beautiful. Then from there now, we sketch. From there now, we sketch. So the highest value, according to the positives, in the y, it's what? It's 5. Then to the negatives, it's 7. Then for x, it's just 2. Okay. It's just what? It's just 2. All right. Do this. Then here, 1, 2, 3, 4, and 5. Then there are 1, 2, 3, 4, 5, 6, 7. Okay. These are what? These are negatives. Okay. Then in x we just have 1, 1, 2, and 3, negative, negative, negative. Then there are 1, 2, and 3 positives there, right? Okay. then we plot this one. So negative 2, 5. Negative 2, 5 is somewhere there. Then negative 1, 4. It's somewhere there. Then 3. 3, 0. 3, 0. It's somewhere here. Then we have 1, 2. It's somewhere here. Then you have 2, 1. It's somewhere here, right? Okay. So this one. So since we have found the graph of this. So since it's not the final one, let it just be what? Let it just be dotted like that. Beautiful. I like these questions. Okay. Then we have this one to say negative 2, 5. Negative 2, 5 is just the same position in this one. Negative 2, 5. Then we have negative 1. No, sorry, negative 1, negative 1, 3. It's here. Somewhere here. So we have, okay, let's just say, okay, we already know this point, okay? Just want to differentiate them, but it's just okay. Then we have 0, negative 1. So 0, negative 1, it's there. And then we have 1, negative 4. So 1, negative 4, it's here. All right. Then we have 2, 7. So 2, 7, negative 7, it's here. All right. Then we have, this one is done. We go to this, the third equation. So we have negative 2, negative 5. So negative 2, negative 5, it's somewhere here. Okay. So this is for y is equal to negative x plus 3. Then this one, since we are done this one, and this one we are done, then this one is for y is equal to negative 3x then minus 1. Okay. There, then negative 4, negative 1, 4. Negative 1, 4, negative 4, it's here. Then 0, negative 3, it's here. Then we have negative 1, negative 1, negative 1, 1, negative 2. 1, negative 2, it's here. Then we have 2, 2, negative 1. 2, negative 1, it's here. Beautiful. Okay. Then there we sketch like that. Okay. So this one will just pass like that. Okay. Then y is equal to x minus 3. Okay. Then we go back now. We go back to what? To our critical points. So we have where x is what? Is half, and where x is what? Is 2. So where x is half is in between here. So we just draw a straight line. Passing through where x is what? Is half, or 0.5 there. So this is where x is half, and where x is what? Is minus 2. Yeah, these are the critical what? The critical points. Okay, where x is what? Is minus 2. Okay, x is equal to minus 2 like that. Okay. All right. Then, since after you going towards this the critical point, then now we follow the what? We follow the regions. So for this linear equation, we are only interested where x is less than minus 2. So we go where x is less than minus 2. So we go, so this is for this linear graph here, this one here. So we're only interested where x is less than what? Where x is less than minus 2. So we go from here, where they are meeting, it's somewhere here, right? So then you're only interested where x is greater than what? Is less than, sorry, minus 2. So this region is the only region where we're interested. Starting from here, going this side. That's what it means here. Okay. Then here, where x negative x minus negative 3x minus 1, for this region, it was this one, this equation, right? This one. Okay. Then for here, we want the region where negative 2 is less than or equal to x less than or equal to what? Half. So which means if there is an equal sign there, which means even 2 will be what? Will be included and what? And what? And half there. Okay. So we'll start from where x is less than what? Less than or equal to 2. Somewhere here. Then we move until to a certain point here. Until to a certain point here. Right. There. Then for this other region, now it's this linear equation. So we say where x is what? Greater than what? 2. So for this one, where x is greater than half, this is where half is. So we're only interested in where x is greater than half, which means it's this side. So we have to connect the graph going this side, like this. So this one is the what? It's the final graph, like that. Like that. So you can plot it in this form, or if you don't want this form, okay, if you don't want this form, if it will confuse you, you can say, for this one, you have to consider the what? You have to consider the breakpoint. Okay, so since we are do y is equal to negative x plus 3 for x minus x less than minus 2, then y is equal to minus 3x minus 1 for minus 2 there 2, then y is equal to x minus 3, then for where half is greater than what? Greater than x, like that. Okay, so we can say y is equal to negative x plus 3. So for this one, you consider the what? You consider the breakpoint. If there are 2, consider both of them. If there's just one, you consider it, and the number which satisfies the what? The condition. So for example, this one, x should be less than what? Less than what? Negative 2, right? So we'll consider putting negative 2, consider the breakpoint, and the number which is less than what? Which is less than 2, which is minus 3, like that. Okay, so if you put 3 there, this one will be positive, then plus 8, there will be 6. Then there, if you put 5, if you put 2 there, it will be 5. Okay, then y is equal to this, you have minus x, then minus 1, then for this region. So since this has 2 breakpoints, we include them both. So x, then y, then there minus 2, and there half. So if you put 2 there. If you put minus 2 there, you have 6 minus there, 6 minus that, you have 5. Then if you put half there, it will be minus 3 over 2, then minus 1, like that. Then you balance it like that. Then you say 2 there, then minus 3, then minus there it's 2, then times that, it's 2, then it's 5 over 2. So it's minus 5 over 2, like that. Okay. Then y is equal to, then x minus 3 for the region where x is what? Is where half is greater than x. Okay. So we have that xy, like that. All right. Then we include at least one breakpoint. So since we have only one breakpoint, we include it as half, and any number which is greater than what? Greater than half, which is what? Which is 1. So if you put half here, you have half minus 3, which will be over 1 there, then common denominator is 2, 2 there is 1, then 2 there is 2, 2 multiplied by that to be 6, then minus 5 over 2, minus 5 over 2. Then if you put 1 there, you're going to have negative 2. Okay. Easy stuff, huh? Simple. Correct. So we have these. Now we can plot. Now we can do what? Can plot like this. Can plot. We can buy the plot now. Since we have everything, we can buy a plot now. Okay. Beautiful. So the highest, so here, there it's negative 2.5. Then here also negative 2.5. Then here it's 0.5. Where else? Even here it's 0.5, right? If you convert these into fractions. Okay, so the highest in y, 6. Then the lowest in y, it's negative 2. Okay. So here you can just say negative 4, negative 3, negative 2, 1. Then 1, 2, 3. Then 1, 2, 3. Okay, like that. Sure. Okay, then we start now what? Plotting according to what? The coordinates which we have. Okay. Coordinates which we have. All right. Then there is a 0. And don't get a 0 in what? The test. But this one is a 0. Okay. So x here, negative 3, negative 3, 6, negative 3, 6, somewhere here, somewhere there. Okay. Somewhere there. Then negative 2, 5, it's somewhere here, somewhere there. Then negative 2, 5, it's just the same point here. Then 0.5, negative 2.5. So 0.5, it's here, positive. Then negative 2.5. 2.5 is in between negative 2 and 3 here. Then here, same point. Then there are 2, 1 minus 1, 2, 1, minus 2. 1, minus 2 here. So you have here like that. Okay. Then you can now join them. You can now just join them like this. Like that. Like that. So this one is just the, this one is just the, this one is just the direct one. If you observe this one and this one, you find that this, if you see this is this graph. But since we just focused on the breakpoints and since we just focused on the breakpoint, we just ended there. But this graph, this it's just linear to go this side, but we're just interested in where x is what is less than what minus 2. And this one we are only interested, this one which is this one, we are only interested in where x is in between minus 2 and half. Then this one you are only interested in where x is what is greater than what half, since half is there. All right, so make sure you like, you follow for more videos. This is Atom Smashers. Till next time.